Hey there. Today we'll be doing a Leetcode daily challenge, that is Subarray sum equals k, and this is today's daily Leetcode challenge problem. And the question states, given an array of integer nums and an integer k, return the total number of continuous subarrays whose sum equals to k. And let's get to know the problem more by actually going through an example, that is 1111 and k is equals to 2. And how do we get this? So it is pretty simple. So we need some subarray, and by subarray we mean the number of contiguous integers that there are, that is called a subarray. So let's say if we have 1, 2 and 3 and also 4, let's say suppose we have this kind of an array. And how do we define subarray? So this continuous part is a subarray, this continuous part is a subarray, and this total part is a subarray. But I cannot say this and this is a part of one subarray. Okay, so we just need to take continuous elements in order to make a subarray. So how do we get this answer as 2 here? So as we can see here, 1 plus 1 is 2. Again here 1 plus 1 is 2. That is why we get the answer as 2. Now let's walk through the example of this and understand the intuition behind how to do it. So we'll get to the notebook. So okay, so I've already written here the example. Now let's get to it, how we actually do it. So first of all, I see I've got 1, 2 and 3, right? So what is the brute force that comes to our mind? That is, I'll iterate through every subarray and get it, right? And by that I mean I have 1, 2 and 3, and I need to form the sum as 3. So what my brute force says is that I'll start from here. I'll take the subarray, this guy right here, that is 1 plus 2, and it gives me what? It gives me 3. And I'll start from here to here. So does it give me 3? No, it does not give me 3. I'll start from here. Does it give me 3? Yes, it does give me 3. So this is one of my summaries. So the answer here is 2, right? And what do we see? We did some repetitive work here. That is, we started from here and we went on till here. But there is an observation that is to make here, and that observation is, let me just write the sum again. That is, if we just sum this up, let's say this is 1, right? And this will be what? This will be 3. And what I'm doing here is I'm just summing up all the values till that index. Okay, the sum here is 1. 1 plus 2 is what? 3. Now what is the sum? 1 plus 2 plus 3, that is 6. Still up till here 6. Fine. Now what can we observe from here? That I got a 3 here. I can clearly see till here I got a 3. So this is my possible answer. But I got a 6 here. But is it a possible answer? From here I see that it is not a possible answer. But it indeed is a required answer, since this is 3, which I explained it to you on the brute force, right? But how do I figure out that in my prefix I got 6? But how do I say that, okay, this is my answer? So what we observe here is the sum plus 1 plus 2 plus 3. It gave me 3. Fine. What do I see here? The sum till this index. What is it? It is 3, right? And how did we get it? I simply said my sum is 6 till here. So let's write this as index. I'll say this one is 0, this one is 1, and this one is 2. Okay. So the sum till 0, 1, and 2. So the sum till second index, that is the whole array, right? What was the sum till whole array? That is 2. And mind you, this is the array. Okay, I've written a here. So sum till this guy is what? It is 6. Fine. And what is the sum till its previous guy? That is up till one index, that is 3, right? So what did I found? The sum till array of index 1 is equals to 3, right? And what do I get the difference as? I get the difference as 3, which is indeed equals to my k, which was given here, right? So which is equals to k, and k is here 3. Fine. So what observation did I make here? I saw if I have a summation till somewhere, I can know that have I got that summation previously somewhere or not. How? By the formula that I have given here. What is this sum? Sum is the summation up till this index and this index could be 0, 1 or 2 or any index, fine, in the array. So this is what I've got, minus the value k that we get here is equals to what my nums array will be. That is, let's say the value is a, and you must have not understood this. I'll walk through a different example to make you understand why this works. Okay, so let me just erase this part right here, and I'll just write this another example, and then it will be clear why have I written this, why have I written k here and not a. Okay, so let's write an example. Let's see, I have something like 2 and minus 2 and something like a 1, a 2, okay, and a 1 here again. And let's say I write a 3 here, fine. And what will be my k? I've said that my k is equals to 3, fine. Now, what was my first thing that I told you to do? The first thing was to sum up the values, right? While going on in the array. So, what is the value till here? I've got the value here as 1. That is my sum. This is my sum array right here. That is I am forming. You need not take an array. We'll get to that point later. So, let's focus on this thing now. So, my sum is what? Up till here 1. Fine. So, is 1 equals to 3? No, obviously not. Now I go on to here 3. So is 3 equals to 3? Yes, it is equals to 3. I got one of my answers. Fine, not a problem. Till here we did not need this. But when do I need this? Now we will see why do we need this. So what is my sum? My sum is equals to 6. But this answer that we find here is 6. But we can see that this value is equals to k, right? So how do we get to know that this is actually indeed this? So what I've written here is, what is my sum? 6, right, minus the value k, that is 3. And what is the required number that I get as 3, right? So I find that if I subtract this sum with k, I know I need to have some element or some array summation up to 3. So do I get 3 anywhere here? I see that yes, I get 3 here. So this could be one of my possible answers. So what do I see? I get my answer as 2 now, since this is forming 3 and this is also forming 3. Fine. Now what do I say? I'll get on to this position. Now I say 7. So I'll do this thing again. So I'll say 7 minus k. What do we get? We get as 4. So do I find 4 anywhere previously? I say no, we do not find it. So we let the answer as 2 only. Now what do I say? I'll go on to the next position. What do I say? I'll go on to the next position. I find the sum is equals to 9. Okay. So now what do we get? I get 9. So again we'll put on this sum minus k, that is 9 minus 3. What do we get? We get it as 6. And I'll check again. Do I get 6 anywhere previously? I say yes. I obviously do get 6 here. So again my answer increases by 1, which leads up to 3 right here. And let's verify this, why this formula will actually work. So I said sum, that is 9 at last here, minus k, right? Minus k, I said let's leave this k as it is, fine. And what was my a that I found here? That is 6, fine. And where is that 6? I find that 6 at this junction, right? This point here I find out 6. Let me change the color. So now I say what will be my k equals to 9 minus 6, if we just take this down here, and k. So what do we get? We again get k is equals to 3. So hence this is proved that we just apply this thing right here, sum minus k is equals to a, we do get indeed the value which we need. If you just see the summation up till here, we got 6, and here we got 9. 9 minus 6 is 3, which is indeed equals to k. That is the subarray that we needed. And how we will know that I previously got something as 6? So there is a data structure that we use, and you might have guessed it. Yes, it is a hash map. So we will just simply take a hash map and maintain an frequency which says, okay, I've got this number this many times. That is, if I have one, I'll just erase this part and explain this again. That is, let's say if I've got 1 previously, I'll just increment the counter as 1. If I've got 3 previously, I'll say, okay, I've got as 1. Let's say if I've got 6, I'll increment its value by 1. So in this way, we can know, have I got this element or this sum previously before or not? If yes, then add it to my answer. If not, you don't need to add anything to the answer. And this is the walkthrough through code. And there is also one more case. If you notice, you'll get an edge case. So I'll just erase this everything here. So the edge case actually is when we get k is equals to 0. So what do we have? Let's take another example, that is 1 minus 1 and 2 2 minus 2, and let's say here we have something as 1, fine, and k is equals to 0. It might be the video might be long, but please do watch it, so it will clear your all your doubts. So when we have k is equals to 0, what do you have? I said again sum this up, right? So I have got 1. Again I've got a value as 0. So what did I say? I'll maintain a hash map which tells me what I have got till now. My sum, that is 1. I've got 1 till now. Then I get 0 right here, which I just got now, but I have not updated into my frequency. So I will not know that is 0 present there or not present there. It will tell me that 0 is not present yet, right? It will tell me 0 is not present yet, but I see that 0 is equals to 0, right? That is the case where you need to handle, wherein the summation leads up to the value of k. Again, I'll explain this if you have not understood this, wherein the summation leads up to the value k. Now, why this? Let's say, suppose 1 minus 1 is 0 here, right? So I get what? The value as 0. But this 0 does not exist in my hash map yet. Since I'm updating the frequency afterward, I'm calculating, I'm doing something here, and I'm updating the value here. But this step has not been done yet, so I do not know the value. So that is why we need to put first the value as 1. So I will say, if I do get the value 0, I'll say I've already got it. I'll just explain this once more if you have not understood this. What I meant here is that uh, prior to the loop that we will do for checking, I'll say in the map, you do one thing, you put the frequency of 0 as 1. So this will handle the case wherein I get this value as correct. And I'll just run through this again. Okay, I'll run this example and show it to you how the answer is coming. So what did I say? I said prior to the loop, I'll say in map, zero's frequency is 1, right? So I did this. Now let's see the beauty of this code. I get 0 here, but in my map now I have 0 as 1, right? The frequency of 0 as 1. So I can say my answer will increment by 1, and this successfully does give me the correct answer. Now I'll move on to the next guy. I see I've got 1 here, fine. I do not need to do anything. Why? Because the sum is equals to 1. So 1 minus, that is k, 0 is equals to a. That is what I get. So is it equals to my value? Yes, it is indeed equals to my value, since 1 plus minus 1 is equals to 0. So what will I say? I'll increment my value by 1, right? That is 2. And now what we see here is, previously I had 1, right? So I need to update my value by 1 more. Why? Because 1 minus 1, I'll just use this, 1 minus 1 is a subarray which is giving me 0, minus 1, and this guy is also giving me a 0, right? So this is one of the part. Sorry, I've just incremented this also. It will be indeed 2. Sorry, this was my mistake. So this is what, and if you just do one more iteration, you will get another answer here. At final you'll get it as 3. So this was what I'd written here, 3. That is why I'd written here 3. Now let's get to the code and it will be clear to you what we have done. It is the same thing that I just showed to you in the example. I took a map, right? I took counter and sum. Sum is taking my summation overall, the sum overall. This is what we were doing here. This is the sum value, and this is my count value, right? So this will be returned as an answer. Now I just did sum plus nums of I, and now I'm doing sum minus k. Why sum minus k? I explained it to you right here. This guy right here that we were doing sum minus k. This is the exact formula that we are checking in the map. If it is present, fine, increment my answer by that much. Okay, this is what we are doing, increment my answer by that much. And what I'm doing, this is what we had been doing there, that is incrementing the frequency of that number. That is, if I got a 1, increment the value by 1. If I get 0, increment the value by 1. So this is what we were doing in this step. At the end of the day, return count, and if you just submit this, it will get submitted. I've already submitted this code and it is accepted here. Okay, and yeah, this is it for this video. If you did like this video, please give a like and do subscribe to the channel.